This is Long Fei. My final project is called mightyscreen. It is a tool for heat selection for high throughput screening. So, first of all, high throughput screening is a combination between biological assays and robotic handling. So it can run assays like in a really large scale, so that it can really speed up the drug discovery process by a lot. So the screening is usually carried out in 384 wow format. So this is the representation of 384 wow plate. So one important thing on a high throughput screening is that you need to include a positive control and a negative control on your assays. So here the wow set is color coded by red circles, the positive control, and the green ones are negative controls. So positive controls represent how your compound should look like when it is active, and the negative control means that how it should look like when the chemical is negative, it's not active. So here is a picture of a robot that is handling those plates. So the robot so each of the wow on this plate is assay. So the robot will just transfer a certain chemical into each of the wow, and each of the wow has a different chemical. And then there will be a reader that can read out the assay, like for example fluorescence from each of the wow, and that will be the readout. So the design of my visualization consists of, first of all, the place selector. So the top line is all the plates that you can select. So each plate can see the heat map, the distribution of the readout, and the scatter plots. So let's look at any of them. So the second component is a channel selector. So I designed there are 4 channels that user can use in this visualization. So each channel you can select any of the readouts of your assay. So for example, for this channel 1 I use FPA, for channel 2 I use FPB, for channel 3 I use FIA. So you can see the distribution. On each of the distribution, the red lines means where the positive controls are, and the green lines means where the negative controls are. So you can see there's a disparity between the two, meaning the window between the positive and negative are good enough, and therefore it's a good assay. So for this readout, FP and FPB, we want to see the readout that is lower than the positive control. And then for FIA, we want to see chemicals that is around the same with all the controls. So let's so another component is the plate visualization. So you draw the plate, like each wow of the plate, and then each of the wow is color coded by the channel 1 reading. So meaning the better the reading is, the darker it will become, and the worse it become, the redder it will become. And then I have 2 scatter plot. So the first scatter plot is the correlation between the reading channel 1 reading and the channel 2 reading. And the second scatter plot is the correlation between the channel 1 and channel 3. So you can see here the distinction between positive control and negative controls are not that great. So meaning this assay is not that optimal. But the correlation between the two replicate FPA and FPB is really good. So they basically lie on one line. So let's take a look at another plate. So on this plate you can see the distinction between those two are greater. So meaning this the quality of the IC is better than the other one, and the replication correlation is really good between the replicates. So the selection of is basically we select on the first two channels, select the compound that has lower reading than positive controls. So you can using a selector to select, and then on the third channel just select where the compound is about the same reading as the controls. So you can see that the only whiles that's being highlighted here is the positive controls, and then there's nothing on the plate, so meaning there's no positive on this plate. So let's look at another one. So we can start from 0. So for this we use the same way to select. So for FPA and FPB we need a compound that is lower than positive control, and for FI we select where the controls are. So you see there are 4 compounds. So you can click any of them, and the chemical structure will be showing. And then there's another coding here is called log P and MW. So it's 2 property that meaning the chemical has a drug-like property. So log P means the overall shape of the compound. So if it's less than 5, it means the compound is drug-like. And molecular weight is a rule that molecular weight lower than 500 is like better compound that is more suitable for drug. So you can see these 2 compounds are really good, but this one is not so good. We can click that off, and then we can go to the next plate, and then we do the same selection, and then we see there are 3 compounds here. So those 2 are not so good. We click them. So in this way, you can quickly select the compound. You can have like an overall assessment of the quality of your assay through the scatter plot. So that's my visualization. Thank you for watching.